So, I am Dr. Lutzmeri, Associate Professor in the Department of Computer Science and Engineering. I am going to take the subject operating system. The subject code is CS8493. The topic I am going to cover is nothing but the allocating kernel memory, how to allocate the kernel memory in operating system. So, the outline of my presentation is treated differently from user memory. The kernel memory is different from user memory, often allocated from a free memory pool. So, the kernel requests memory for structures for varying sizes. So, kernel is the heart of the Linux operating system or an operating system. Some kernel memory needs to be contagious. It should not be discontinuous. It should be continuous. So, buddy system. So, might have studied buddy system data structures. So, allocates memory from fixed size segment consists of physically contagious pages. So, memory allocated using power of 2 allocator satisfies request in unit size as a power of 2, request rounded up to highest power of 2. When smaller allocation is needed than is available, current chunk split into 2 buddies of next lower level of 2, continue until the appropriate size chunk available. So, how to calculate the buddy system? So, we will be having 256 it's divided into 128. So, left and right, then it will be calculated divided into further 64 buddy left and buddy right. Then we will be having say A is there, B is there, and again 32 and 30. Slab allocator, it's an alternate technical strategy. Slab is the one or more physically contagious pages. Cache consists of, cache is the fastest smallest memory that is recently used thing only there compared to main memory, it's faster. So, cache consists of one or more slabs, single cache for each unique kernel data structure. Each cache filled with objects, that is instantiation of the data structure. So, when a cache is created, it is filled with objects marked as free. So, when structures are stored, objects are marked as used. When cache created, object will be free. When structures are stored, when I am going to store it, so the objects will be marked as used. If slab is full of used objects, next object allocated from empty slab. If no empty slab, new slab will be allocated. So, benefits is no fragmentation, fast memory request allocation. How the slab allocation will be? So, we will be having 3 KB objects, then we will have the caches. So, physically contagious pages, the slabs will be allocated. So, 7 KB objects, then we will be having the caches, the request will be allocated fast. So, other issues, what are the other issues? Pre-paging to reduce the large number of page faults that occurs at the process startups. So, that if pre-pages are used, they will be referenced, and it is unused, the memory will be wasted. Assume S pages are pre-paged and alpha of the pages is used. This cost of S into alpha say pages false, so are less than or equal to or greater than is the cost of pre-paging. S multiplied by 1 minus alpha unnecessary pages, alpha nearly 0, pre-paging losses. Page size selection is also taken into consideration. It leads to fragmentation, table size, IP, overhead and locality. So, TLB reach is the amount of memory accessible from translation look-aside buffer. So, TLB reach is equal to translation look-aside buffer size multiplied by page size. So, increase the page size is may lead to increase in fragmentation. Provide multiple page size that allows the page sizes an opportunity to use them without an increase in fragmentation. The program structure will be, you have to initialize the data. Each row is stored in one page. So, 128 by 128 will be having 16,384 page faults. So, when I is equal to 0, j less than 1, j is equal to 0, j less than 128. So, we will be having the data I comma j 128 page fault. Then why frames will be used in IO must be in memory. So, this time it should be in memory buffer, that then only have the faster access. Operating system example XP and Solaris. So, I will be seeing XP with the demand paging with the clustering. So, we will be having working set minimum and working set maximum. The process may be assigned as many pages up to its working set maximum. So, when the amount of free memory the system falls below a threshold, automatic working set trimming is performed to restore the amount of free memory. So, maintain a list of free pages to assign. So, lots of free threshold parameter, test free, threshold parameter to increase paging. So threshold parameter to meet swapping. Paging is performed by page out process. Page out scan pages using modified clock algorithm. Possible question. So most systems allow programs to allocate more memory to its address space during execution. So data allocated in heap segments of program is an example of such allocated memory. So what is required to support dynamic memory allocation in the following schemes?